I am Zawi Abdelhalim from National Higher School of Advanced Technology. I present this work on open source software Ch4 Max for simulating Ch4 scenario relevant to OSI mission. In CTBTU OSI, ground penetrating radar is used to detect and characterize subsurface anomalies potentially linked to underground nuclear tests. It supports both wide area survey and target investigation, aiding inspector to locating buried structure or disturbance. How to? Okay, the most important thing of this is to help inspector to enhance their skill in interpretation of proposal interpretation after field operation. And thank you.
Okay, hi everyone. I'm Dr. Dan Bodis from the University of Birmingham. I mainly do gravity survey on OSI. So the problem with gravity measurements on OSI is they're really slow, and tempting as it might be to banish me to a remote search zone for a long period of time, it's not the most efficient way of doing it. So what I've developed here is a way of speeding up gravitational measurements by effectively locating where the samples are. And I'm doing this using an information based approach. So I'm doing an inversion process during the actual collection of data, and then I'm getting a posterior output out of that and a range of models which I can then draw from and find the areas of those models where the measurements are giving us the greatest uncertainty, and I go for those. So what I've done here is I've tested it looking for a tunnel in quite a large area, and it shows both an improvement in the speed but also the accuracy of the overall result of where the tunnel is. If you want to find out more about it, come and find me. I'm on poster board 2.
Ladies and gentlemen, good afternoon, good morning, and my name is Gleb Zasimov. I'm from Russian Federation, and first of all I would like to thank you, all of you, for coming here, and it's a great honor for me to be here and participate in this excellent event. I'm a representative of Russian Research Institute of Automatic Techniques. It's our institute. It's a leader organization of State Atomic Energy Corporation, Rosatom, in relation to CTBTO. And we work with implementation and carry out our work in research as follows. Develops methodological and hardware, software for support for OSI activity. We involves in research the geophysical and radionuclide data for solve this problem for CTBTO. Also, we develop seismic system technical support for OSI activities for passive resonance seismic. And we develop software for include complex CTBTO compliance monitoring based on the update algorithms of digital geophysical and processing, which provides all full scale of continuous seismic and infrasound data processing. So, if you would like more and talk with us, please, I invite you to our poster 3.3 097. Thank you in advance.
Good morning. My name is Rolf Häfner. I work for Sonic Kona from Germany. We were tasked to implement a resonance seismometry algorithm. Resonance seismometry means we look for subsurface anomalies using resonance effects. Our task was to use earthquake data for this job. So with only a few seconds and limited number of events of data, we really have to look at a variety of parameters from time domain. So we look at scattering or frequency domain, looking for resonance to find these subsurface anomalies. In the end, we have to combine a lot of different results from different methods to get a map that we can interpret and try to find interesting areas for further inspections. Thank you.
Hello, my name is Julien de Trou-Lanversa. I'm from the Hong Kong University of Science and Technology. So in my work, I'm going to talk about something that is, I think, rarely discussed in this conference, which is the zero-yield standard, very low-yield test, and subcritical test. So subcritical tests are nuclear experiment, laboratory-scale nuclear experiment conducted by countries like the US, China, or Russia in underground chambers within metallic containment vessel, where they irradiate and compress plutonium to try to recreate the early stage of a nuclear weapon explosion. This is for the stewardship of the arsenal. Now, we know that the CTPT draws the red line between prohibited and permitted experiments with the zero yield standard. That means any experiment that becomes supercritical is prohibited. But today there is no method, no protocol, no verification method to verify that a past very low yield test complied with the zero yield standard. And that matters because in the last Trump administration, the US government accused, for example, Russia of non-compliance with the zero yield standard at very low yield test. And this led to discussion in the US government that maybe they should resume full-scale nuclear tests since Russia did not apparently comply with the moratorium. So in this work that I'm going to present, I'm trying to develop verification method based on gamma spectroscopy that would be taken from the metallic vessel where the test has been conducted, and you see that we can infer some conclusion on whether the test breached the zero yield standard by going supercritical. Thank you for your attention, and I'm happy to discuss with you at my poster session. Thank you.
Good morning. My name is Josephat Mulwa from Kenya. So my poster is dealing with on-site inspections in challenging environments. And this builds on the discussions held during OSI Workshop 24, where the objectives were to consider on-site inspections in different environments, which could be potentially challenging. And so in this poster, I examine potential challenges in these environments. And some of the challenges may include the reduced mobility of the IT, adverse effects, other than safety issues. The topography may be challenging, and then limitations on OSI techniques. I'll be very happy to welcome you to board number 10 so that we can discuss about these potential challenges in young volcanic centers. Thank you very much.
Hello, I'm Sebastián Camacho from Ch4. Well, a quick overview of our work is that this is about the detection of underground caverns created by nuclear explosions using the seismic reflection method and seismic wave propagation simulations. Accurately identifying underground cavities helps with understanding subsurface structures quickly, which can help the OSI team with time schedules. To accomplish our goal, we used 2D seismic data obtained from seismic wave propagation simulations, different medium configurations, and typical seismic processing to detect anomalies indicating explosion-induced cavities. The most important finding of our work is that our approach can reliably identify underground structures, providing a framework of seismic responses, allowing rapid identification of explosion-induced cavities. If you want to know more, I'm at poster board 12, or you can send an email for a more detailed talk at this address. Thank you.
Good morning, everyone. My name is Vladlen Afonin. I'm here with my colleague Alena Mukhortova. We are from National Research Nuclear University MIFI from Russia. And our poster is about ensuring integrity of information transmitted from inspectors' tablets to the server in the receiving area. This process typically happens after inspectors have collected all the data. And we are going to tell you why data integrity is important for OSI teams and what tools exist for ensuring that data was not tampered with during the transmission into the receiving area. In our research, we have compared message authentication codes and digital signatures as means of ensuring information integrity, both in terms of their features and properties and their performance. Like a little snippet, our main recommendation to the OSI teams is that we recommend using MACs, message authentication codes, if non-repudiation is not required, and digital signatures otherwise. If you want to find out more, please feel free to join us and chat in front of our poster. Thank you so much.
Go to the previous slide. Yes. So, I will be presenting the posters for boards 15 and 16, where we have results from our 2022 and 2023 on-site inspection field tests. In 2022, we had a field test in Austria in a mountainous environment. In 2023, in UK, on a farmland over the Channel Tunnel. These were mimicking OSI-relevant targets. And over these targets, we were doing OSI techniques development work, testing hardware, software, workflows, procedures for techniques, active seismic surveys, resonance seismometry, gravitational field mapping, and electrical conductivity measurements. On these two posters, you will see results for the seismic and non-seismic techniques. Now you can turn to the next one. This is just, Louis is here.
Hello. Sorry. So, if you want to see these results, please come to our posters. This is a snapshot. On the left side, you can see the 3 profiles we conducted in this first field test. The middle column shows already some kind of integration of the different results we got. So, for example, on the top, you have results from electrical resistivity tomography. You can see different areas with higher conductivity, with lower conductivity of the terrain. So we think we identify already some caves, some voids below the surface at different depths with electrical tomography, which were confirmed with seismic techniques.
Exactly. And more of the results, please come and talk to us on the posters 15 and 16. We are standing ready there to talk with you.
We made it.
Hello, my name is Kirill Hrustalov. I work for OSI Noble Gas Techniques. And in this poster, I'm going to present to you the tool which we have developed together with my colleagues on how to do the data assessment for the noble gas and particulate data which is collected during the on-site inspection. So after the data samples are collected and processed in the lab, we need a way to do the data assessment and integration of this data together with other techniques. And this tool, the software which we developed, allows for the inspectors to easily interpret the data, compare it with known isotopic ratios and scenarios, and produce reports which can be then later integrated into the overall inspection report. So please come to my poster and I will be happy to explain you in details how this software works. Thank you.
So, good morning, everybody. My name is Ale Drolens from the PTS. This poster is not about helicopters. It's about the equipment that we put on airframes as part of an on-site inspection. In particular, we focus in this poster on the initial overflight configuration, which is video, still photography, and position finding equipment, and the multispectral configuration, which is an array of sensors focusing on the visible, the infrared, and the use of a LiDAR. The poster focuses on how we've been adapting the configurations to make sure they're as easy to install as possible, reducing the physical footprint, making them easy to use during in-flight operations, and ensuring that the data flow and the processing stream is as fast and reliable as possible. Come fly with us on board 18 later on. Thank you.
So it's me again. I have two posters. Fortunately, they're next to each other. So my other poster is about the development plan for the OSI noble gas techniques for the next development cycle. So we always go between preparations for integrated field exercises and then development cycle. And we already, even though we are preparing to IFE, but we have to think how we can develop the OSI techniques further and improve the experience. So my ideas are, well, not just my ideas, but our ideas about how to improve the sampling in terms of logistics and improve it into so that we can collect more samples and increase the throughput of the inspection team. Also, we are working on how to improve sampling techniques and preparation of the data in order to process, which is partially covered by the other poster. And also we are working on development of internal inspected area, kind of mini IMS network, which will allow us to collect samples and discriminate between samples which may be affected by sources outside of the inspected area and sources inside the inspected area, which is very important, of course, as you can imagine. So I have some other ideas which we brought into this development plan, and please come to our poster and I will be happy to explain to you all our ideas. Thank you.
Hello everyone, my name is Rémi Cabalchini. I work for the PTS inside the EP section in OSI, and I'm presenting today some results we have been getting from last field test on a nice solution called a data transmission system. It's a way to transmit data from the inspection area to the base of operation. And we have many challenges for that, to develop this solution, because I would say maybe thanks to the treaty, we can't rely on commercial solutions. So we have to develop a pilot solution. And my poster is about like the latest results from the field tests. So we went to Austria and to do some long testing range, etc. And the results are promising, and we hope, hopefully, we will play with this equipment during the next IFE. So if you want to know more about the results and the solutions, I'm in the next room in the next hour. Thank you very much.
Hello, it's great to see a full room for such an important, interesting subject. And there are plenty of good seats over here. You don't need to hide in the back, Andrew. My name is Matthias Aldener from the Swedish Defense Research Agency. I'm going to talk about noble gas. So if you're curious in an on-site inspection, so if you're curious about inspectors, why they have big noisy machines that punch holes, they fill gas bags, big, large balloons, and what happens with those balloons afterwards, you should come see my poster at number 21, and I'll give you the tour of it and how we improved it for the exercise in Hungary. Thank you.
Hello everyone, my name is Shaji Matthew, and my e-poster is about the application of advanced seismic waveform immersion for detection of underground cavity. We all know that detection of cavity is a crucial part for on-site inspection, and active seismic method is something which we want to evolve, and obviously processing is a key part, and there's a lot of challenges. So this is a part of the test which we processed for my PhD when I was part of the Harvard University, and we used a joint travel time waveform inversion method, and it showed a very good promising result. And I'll be presenting the result on one of the test lines, and want to discuss, what are the way forward and the challenges, and if you want to know more, please come to poster number 22. Thank you.
Hello everybody. My name is Andreea Tole. I'm from National Institute for Physics from Romania. My poster presents the lessons learned from site characterization near headquarters of NIEPS in Măgurele using active and passive methods. If you are interested to see what were the challenges that we faced and what was the limitation of our approaches and the results that we obtained, please come visit my poster at board 23. Thank you very much.
Good morning, everybody. My name is Alberto Baldini from Enea. Cross-contamination is a serious problem not only for on-site inspection, in general for many scientific applications, but for the on-site is a crucial point because there are many samples in a very short time. So for doing experiment and measurement that are meaningful, you need to be sure everything is proper, perfectly cleaned, sample orders are okay, device, tools, everything must be okay. So there are some protocols that must be followed to have the result in the proper way. So this is, I will present in my poster, so for the moment I say thank you to you.
Good morning, ladies and gentlemen. I'm Yang from China. There are some problems of my document, so I just print it and show you here. Maybe not very clear, so maybe later you can warmly welcome to the board 29. Let me do the introduction. I'm very proud to introduce our lead-free radiation protection clothing solution for inspection team. Everybody knows the efficiency and the safety equipment is very important for the inspection team and also the clothing. But now the clothing material is, there are a lot of shortcomings about the overweight and the high thermal load. It is not very suitable for the inspection team. Consider to this issues with research and development of new technical material. It is including 4 layers on this kind of material. And also we do the key performance comparison between the old material, clothing material, and our new technical material. So there are a lot of different and a lot of advantages. And also, this kind of new material has been used on a lot of aspects, especially in the hospital. So we think maybe it would be applied to the OSI. Okay, thank you very much.
Good morning. I'm Begoña Pérez from PMAT in Spain. I'm going to talk about a transversal issue that is in on-site inspection, that is radiation protection. And I'm going to talk about the principles of radiation protection and how to measure the dose in personal dose, internal and external, and how to avoid the exposure, and it's necessary, of course, planification of its activity and training a lot, and that is all. Thank you.
Good morning, everyone. My name is Michael Lavelle. I'm the OSI Health and Safety Officer, along with my colleague, Joseph. Joseph, stand up, let everyone see you. There you go. Why did he get a round of applause and I didn't? We took a look with a pressing need to revitalize and retune the health, safety and security for initially the IFE, and then obviously it has to have a relevance for post-entry into force. Although from my very recent experience, and controversially I might say that an IFE seems to be more complicated from a health, safety and security point of view than possibly a real OSI, but don't quote me on that. So we've identified 3 pillars which are essential to ensuring the health, safety and security of all participants within an IFE and then hopefully on an OSI. Those pillars are procedures, training and equipment, and they are completely interlinked, and the idea is that we enhance the capability of health, safety and security within IFE or an inspection team to give them a high standard before that is supplemented by the host country or the inspected states party. Come see our poster, you'll spot us. Thank you.
Good morning, everyone. I am Marcelo Fernandez from Argentina, from the Nuclear Regulatory Authority. I'm the 3rd training cycle health and safety officer. Okay, I will present a poster about a new approach to the contamination control and the decon light and at the base of operation. Please come to see my poster. Thank you.
Hello again, I'm glad to see you're filling up the seats. So I'm still Matthias Aldner from FY Sweden. This is a collaboration work, and I will not be at both posters, so I will have help of my colleague Klaus Ellengren at this, at position 34. So if you're curious about this very interesting poster about the scenario in Hungary for the build-up exercise and how we implemented radionuclide detections in a tunnel scenario, this is the poster to go. You can spot the trumpet that didn't really work, and you might also get answer to the question as why does the scenario task force run around with syringes at base of operation at night when the inspectors are sleeping? So, see you there.
Good morning, I'm Nalin Disilla from Sri Lanka, and this is an idea that developed me and my colleague Goyum. So, we have some experience when we using software and other assistance in the field. It is in some areas that things are not as expected because there is less coverage. So we are thinking whether we are over relying on technology and software, because we know that when it comes to OSI, nothing is predictable, and you can't have predetermined sort of a mode, because we are thinking whether the inspectorate is coming to a semi-automated mode, because it's going to be disturbed once we think about the real scenarios. So here the idea is that we may not over-rely on software and tools like that, but that can be utilized for the objective. But again, if nothing is worked still, we have to deliver, so we have to go back a bit of old school and blend things with software and human creativity to find the better outcome. So we can discuss these ideas. I'm inviting you to my poster session. Thank you.
Yeah, hello, my name is Monika Risse and I'm from the Fraunhofer INT in Germany, and I'm presenting today some measurements we did with a nail detector. This is a sodium iodine crystal which is doped with lithium-6. So we have a normal sodium iodine detector which enables us to measure some gamma spectra, and we can also do via nuclear reaction some neutron measurements at the same time. So we can either detect and identify these both. And on there you see some spectra, no, on there you see some spectra for the different neutron sources, and you can guess that we can distinguish them. And this is about the poster mainly also is about that we have to optimize the setting for both, for the neutron and the gamma measurements, and that is not that very easy. I can do the neutron measurements quite well and the gamma measurements quite well, but for the PSD to find the right settings is a bit complicated. So I would like to chat about this with you at my poster, and you will find me at number 36, or just watch out for the red blouse.
Good morning. My name is Peter Labak. I'm from On-Site Inspection Division, and I'm going to talk about the realistic inspected state party played during the on-site inspection exercises. And the purpose for that is very simple. The OSI exercises are to validate the capabilities of on-site inspection in the realistic environment. They are run using the scenarios, and if we have this environment like scenario plus inspection team, there must be a counterpart to that, and this is the role of the inspected state party. Our poster talks or presents our experience from build-up exercise 24 in Hungary last year, and it's about how we interacted with the inspection team in the areas of logistics and other support, and also how the inspection team was set up and had the meetings and was preparing for mimicking the work of the inspection team during the exercise. We will also discuss how the scenario elements are implemented through the inspected state party role during such exercises. The contribution was prepared together with Luis Gaia Piquet and Nalin da Silva and some other inspected state party members. And you are welcome to join the stand 38, and we can have discussion on this topic. Thank you.
Hello everyone, I come back again. I'm so glad, I'm glad to show the anti-counterfeit total solution for OSI. Everybody knows the OSI is a verification mechanism that would strengthen the confidence among states in the CTBTO. And the culture of anti-counterfeiting for OSI would be essential for building confidence in all of the activities. And please look at this part. We have already printed the code on the container. It is a kind of new technical invisible quantum state code, but it is visible under the certain light with the certain spectrum frequencies. And also it can be read fast. Reading speed is only 0.5 seconds. The most important thing is it can print on different kind of spaces. The whole system has three parts. The first one is the quantum state code system and the specially designed printer, and also the PDA reader. This system has already been used on the marking of small arms and the light weapons. Okay, thank you very much.
Hello. I think here we try to bridge the gap between the IFE and the OSI, but the thing is that OSI, you can't create it. It will happen, hopefully. So let's say the IFE, we have a lot of artificialities and some injects as well. So we were trained in a way that to see how the OSI going to be, which we have no idea. I mean, we have an idea, but there are going to be a lot of variables. There are going to be a lot of undetermined aspects when we conduct an OSI, if it ever to happen. So how we transform our IFE sort of a training into OSI, is still a gap, but we have to, when IFE has to be designed in a way just minimizing the injects and artificiality in a way that we are prepared to do an OSI when it is required. So I think the picture is going to tell the story. So I'll try to explain it. IFE is a bit rigid and well ordered, but when it comes to OSI, it is not. So how we're going to bridge the gap, it's time will tell us. Thank you.
Hello, my name is Wing. I'm from Nagasaki University and doing my PhD in advanced preventive medical science. So basically, my research, I explore affected area after Fukushima, how the so-called the model co-expected process, which is recommended by International Commission on Radiological Protection, has been successfully developed, successfully implemented in some of the area in Fukushima area after a nuclear accident, and how this can be developed in other areas. There are still challenging to have a recovery process. So I come up with the idea how this process can be supporting to the on-site inspector, and in case when they have to experience radiological contamination environment. So in this poster, I will be talking about the adapting that process, so-called cooperation between experts and stakeholders, and to strengthen the CDBT on-site inspection in radiological environment. And I also going to tell you why trust and communications are as vital as technical data during inspection. And of course, sorry. So of course, you are welcome to come to the poster, and then I will explain you more. Thank you so much.
Hello everybody, my name is Martina Capponi from the Italian company Geomatics Research and Development, and with my co-authors we prepared this poster about the development of a Python software that we developed for processing and visualization of gravity field data to be exploited in the context of CTBTO on-site inspections. Gravity anomalies related to cavities or collapsed zones can provide, in fact, clues for the identification of underground nuclear explosions. And, but this signal can be small, so we designed a tailored software specifically for microgravimetry applications, in which we applied all the corrections to adjust the gravity measurements. And the result is a user-friendly tool that helps the inspection team to obtain reliable and corrected gravity data, making it possible to highlight anomalies that could refer to nuclear explosions. If you're curious, you can find me at my poster. Thank you.
Hello, my name is Anton, and I'm a communication officer in OSI. I'm responsible for the network, for the OSI communications network, and this network exists only because the inspection team has the right, according to the treaty, to always communicate between themselves and back to the PTS at whatever moment they wish to. So what I'm doing and what we are doing is that we try to stay up to date, and we constantly follow the technology. And I invite you to join my poster, my site, and we could discuss in more detail. The only thing I can tell you is, as long as we are dealing with this, we will push the technology forward to be at the pinnacle of the most modern technologies available on the market. Thank you very much.
Good morning, everybody. My name is Simon Summers. I work in the On-Site Inspection Division Policy Planning Operations section.
And I have two posters to present to you. The first one, in fact, both posters are part of the exercises which were conducted and are going to be conducted within the framework of the ongoing on-site inspection OSI exercise program for 2022 to 2025. The first one, which you see on the screen behind you, is on the OSI build-up exercise, which was a medium-sized integrated field exercise conducted last year in Hungary with approximately 150 participants from 37 state signatories. A number of you I see here in the audience. This was the first integrated exercise conducted under the current program, and this means the testing and validation of equipment and technique application, personnel and training, and procedures and methodologies. It was also the largest and the most complex OSI exercise conducted since the integrated field exercise, which we held last in 2014, and a precursor to the next IFE, which is the subject of my second presentation. Our poster on the BUE provides some general information on objectives, scenario development process, the implementation of the exercise, the role of the Operations Support Center, as well as the techniques, concepts, methodologies, and systems which were applied. My co-author, Andrew, who will present shortly, and my colleagues in the Policy Planning Operations section, and myself, will be happy to answer any questions you may have at the poster. And the second one, if you could bring that up. Are we onto it already? Good. So this is on the next integrated field exercise. For those of you who don't know, integrated field exercises are amongst the largest form of on-site inspection exercise. It provides an optimal platform to test virtually all elements of an on-site inspection prior to entry into force. This particular IFE, the next one, will be designed to test and demonstrate the maintenance of existing capabilities, to demonstrate the progress made since the last IFE and the last build-up exercise, and newly development elements. And it will also allow for the review and the evaluation by an external evaluation team of policy, operational support, logistical, technical capabilities from a holistic and cross-cutting perspective. The next IFE, the plan is to conduct it now in 2026, and if all goes well, it should be hosted by the Republic of Namibia, with approximately 200 participants lasting between 6 to 7 weeks in an area of up to 1,000 square kilometers. Yep, wrapping up. Yeah, just to say, so you're welcome to come and talk to us if you have any questions about either of those two exercises at my poster. Thank you.
Hello everyone, my name is Julius Kozma. Simon kindly introduced Operations Support Center slightly. So my colleagues and I from Policy Planning and Operations section, we prepared a poster on Operations Support Center and mostly about the last 4 years developments in preparation for the build-up exercise, how the Operations Support Center performed during the build-up exercise, and what are we going to prepare for the next integrated field exercise. Operations Support Center is the key supporting element here at the PTS headquarters for inspection team in the field. So if you have any questions, we are at Kwang and I will be at the poster session, stand 46. We are ready to answer any of your questions. Thank you.
Good morning, everyone. My name is Andrew, and I work with Simon Summers in the Policy Planning and Operations section in the PTS On-Site Inspection Division. You've already heard a little bit about the build-up exercise that was last year in Hungary, and the upcoming integrated field exercise that we hope will be next year in the Republic of Namibia. But the exercises, plural, that started off the current suite of OSI field exercises were conducted in 2023 in Bruck-Neudorf, Austria. And it was a series of so-called directed exercises. To learn more about the challenges and the lessons learned from running simultaneous exercises on field operations support, OSI laboratory, and also data flow operations, as well as how to work with over 75 members of an inspection team trying to practice and test and validate activities that hadn't been used since the integrated field exercise in 2014. We'll be very happy to answer your questions and talk to you more at poster number 47. Thank you.
Good morning, everyone. My name is Valentine, and as we've learned so far, the OSI is a complex scientific and technical operation, and it relies on advanced technology, a lot of teamwork, and meticulous procedure to verify compliance with the CTBT. So the on-site training program uses the learning management system as a core part of the linear training program. They provide role-based training that supports face-to-face courses, reinforces skills, and delivers ongoing refresher training. The tools include scenario-based interactive e-learning, online assessments, software simulations, remote software training, video tutorials, and immersive virtual reality tours. So we are trying to maintain inspector readiness and capability at all times for inspection tasks. So join us at poster number 48 to learn more about this. All right.
Good morning. My name is Tamás Éles, and together with my colleagues, Salana Harmati and Jörg Sauer, we were analyzing and taking a look at requirements for larger scale support structure for OSI exercises. As you're aware, inspection team has a limited deployment capability, or almost expeditionary capability to sustain their camp and operations, but that's designed for 40 people. During any exercise, pretty much the same infrastructure is shared by an additional 80 personnel who is relying on it, and it creates challenges to make sure that all participants are actually well supported, as well as real-life support by prearranged mostly by contractors are actually fitting into the game, and to make sure that the IT's ability to sustain its own capability can be still independently evaluated. If you are interested, we would be happy to answer any questions at booth 49. Thank you.
Good morning, everyone. I am Barbara Nadalut. I am Equipment Implementation Officer at the On-Site Inspection Division for the Radionuclide Techniques. I'm presenting two posters in this session. The first poster is about the new technology infrastructure, information technology infrastructure at the On-Site Inspection Field Laboratory. This is comprising a complete, was undergoing a complete restructuring with now some hardware redundancy and host-pair configurations implemented, as well as enhanced robust backup strategy with redundancy. We will also present the insight on the new laboratory application, which is in charge of information management within the laboratory premises. And we have the honor to host with us as co-author also the software developer. So if you are interested, please join us. Our poster slot number 51. We are in the far corner of the first salle on the left side. Thank you very much. Our second poster, I will present together with my colleagues, is for the, all the on-site inspection radionuclide techniques. Nominally, we will present the deployment and the operational configurations for the equipment assigned to gamma radiation monitoring, to low resolution and to high resolution energy resolution analysis, and the equipment in use for environmental sampling for both particulate and noble gas techniques. If you are interested, we will be also at spot 52, very close to the other poster. So I will be there to answer any questions. Thank you very much.
Hello. It seems to be I'm going to conclude the session. I think when it comes to OSI, the variables, unpredictability, and the difficult to predetermine things are the essence that we have discussed, me and the other speakers. So such variables and difficulty to predetermine creates a lot of scenarios. It means number of scenarios that will take in place in an OSI going to be immense. So all these scenarios could not be practiced physically because of cost and all other logistical issues. So the answer going to be maybe a prototype test site and using the new technologies, things like simulators and AI technology. So we see even in OSI there are some aspects, simulators and technologies are utilized in a manner, but we have to blend it into the training just to test different scenarios that could not be physically done in different environments, because Ch4 also discussed the different environments. So if we can have simulators and prototype training, so we can test more scenarios that could not be practically test but may happen in an OSI. Thank you.
Now, that concludes our lightning session. Thank you to all the speakers. As you can see, we have a very, very interesting range of posters. The best part is about the start, which is that we get to go there and talk to the authors at their posters. So please, let's all move then at 12 o'clock. I'm not sure if it's already changed, but from 12 to 1. See you there.